Section 11.7 is on amorphous solids. It's actually a very short section. Remember at the beginning of section, I want to say 11.3, we were talking about the difference between crystalline and amorphous substances, and at that point we defined them as amorphous substances as being ones that did not have long-range order. We talked about the repeating pattern, the long-range repeating pattern that we see in crystals, and that is not present in an amorphous substance. Amorphous solids have no three-dimensional structure and no pattern. So the molecules, as we talked about in class, haven't had a chance to orient themselves or line themselves up as they enter into the solid state. So there's no order to them or structure to them. They just kind of get frozen in place. It may or may not be in the right place to create a crystal. You can create an amorphous solid by cooling a liquid very quickly before it has a chance to crystallize. It's not exactly the same as what you did in lab with phenylsalicylate. In that lab, you were cooling phenylsalicylate quickly, but it stayed as a liquid. It didn't solidify, and so you weren't creating an amorphous substance there. You were just creating a liquid that was below its freezing point, which is a different situation. In this, you would need to cool it even faster and at an even more significant temperature, where you would just take away the energy so it wouldn't have that kind of motion that's associated with liquids anymore, and everything would just stop moving, but they would stop moving in the wrong place. So they wouldn't be networked or organized or patterns. The best example of an amorphous solid is glass. A lot of people think that glass is a liquid. There's a pretty common misconception that glass is just a really thick, slow-moving, very, very viscous liquid. And the so-called proof of this is in the window panes, really old window panes in old houses, where people see that the glass is thicker down at the bottom of the window than it is up at the top. So they assume that the liquid has been slowly, the glass has been slowly flowing downward over many, many, many years. And that's why the liquid or the glass is so thick at the bottom. Actually, it's not a liquid. Glass is totally a solid. It doesn't flow over time. Back in the day when those houses were being made and those window panes were being made, the techniques that they had to make glass weren't as fancy as they are now. So the glass panes did not come out all of uniform thickness like what we have now. And as a result, there would usually be one end of the glass that was thicker than the other. And so when they were putting the house together, of course, they would put the thick end of the glass down on the bottom of the window, because if they did it the other way around, it would be more likely to break. So that's the reality of glass. It's definitely not a liquid. And if you don't believe me, there's a little section in your book that talks about it as well. And so there you go. There's no study question for this section. It's such a small section, and there aren't any homework problems either for it.